is going to sort of get to the core of all these. The only difficulties that you could experience here. I actually want you all to call this one. What are the early starts on A and B?
0.
Zeros.
4 and 5.
Okay, let's just make sure that we see how this thing goes. So A and B have I've got these things.
Yeah, it's different.
Right, so A and B have no predecessors, they come out of the start block. C has, I need to have A and B in here, sorry. And then D comes out of C and E comes out of C, so that's the graph. All right, so the early start times on A and B are 0. The early completions would be 4 and 5. What is the early start time at C? 5. I'm going to put it in red. Remember on the way out, on the forward pass, if you do have a conflict, you're going to take the maximum. You don't need to remember this is a rule. You can just see, C's got to come after A and B is only going to get done at 5. So although A gets done at time 4, you can't start C until both A and B are done. So that's why it's 5. Okay. All right, C, obviously going to complete at time 11. So we get started on D and E at time 11, and then we're going to complete these guys at time 16. All right, so the project duration is 16. And then we use as the late finish time on D and E, the project duration, which is 16. And then I'm just going to go backwards. So at C, it's 11. Now, I want to sneak one on you here. Allow me to change this one to 6. Okay? I'm changing that one to 6. You okay with that? The reason why is I want to have a fanning effect as well, so you can see what happens at C. So this one would be 17, 17, and 17.
So you just picked the largest one, that's why you have 5?
Yeah, on the way, on the forward pass. So the project duration is 17. Okay, so the convention is the project duration becomes the largest, it's the late finish time on all nodes connected to the endpoint. 17 minus 6 is 11, 17 minus 5 is 12. So I want this one in red. Now you can see I'm going to get started on this one at time 11 and this one at time 12. So when do I need to get this one done by?
10.
11. Okay. See, I'm getting you a min rule here. I use the max on the way out, but on the way back it's min. But you can reason it for yourself pretty easily. This one wants to start at 12, this one must start at 11, but we've got to get this one done before either of them, so of course it must be done by 11. All right, so I was able to get the late finish on A and B is 5, and just wrap it up. So I'm able to calculate my slacks. The slacks are just the difference between the late start and the early finish. The late start and the early finish on every node. So it's as follows. And B is 1, and that's 0. So my critical path is what? BC what?
BCE.
BCE. You're going to have to manage activities B, C, and E. You get the contractor there on day 0, hammer it through, make sure C is there ready and waiting, and B comes off the job, C slots in, and so forth. Not quite as critical to do A and D as rigorously, but there's only one day slippage possible across activities A and D. and they're connected through this activity here anyway. So, in fact, just about everything here is super critical. I wouldn't want to let anything slide. Questions about this one? I think this one's got all of the richness of the fan in, the fan out. That's all there really is here. So I'm going to go ahead and do the one in the notes as requested, but it's just a lot larger. There's nothing more to the stuff than that one.
So if this is on the test, would you give us just that little graph on the left there?
That's
and
it.
we have to construct everything? Yeah. Give us the activity and the time.
Yeah.
Can you find the slack again?
The slack is just LS minus ES. So it's this minus this in every case. Anything else on this one, folks? If you do take pictures, feel free to post them on the, one of the wikis. So if anybody needs to, that'll help anybody.
Do it a couple times.
All right, just before we get to this last one, let me just tell you what crashing involves. So you start the project, and you start operating, and you look a little bit on the day, and you see, of course, might start, right after B. But by the end of C, you're starting to get worried about actually completing the project on 17 days, at 17 days. So you're starting to think about expediting. Now, just about any contractor is going to be prepared to do the job in less time for a markup. Of course, there's some technical limits as to where a job could go. Like if I were to be, if I was contracting to tile your house, let's say you got a 4,000 square foot house, I could probably do 4,000 square feet in 6 days, normal, right? I would maybe be prepared to do it, the absolute minimum would be something like 2 days. And if I'm going to do that many square feet in 2 days, I need to get extra people in. Maybe I'm just a 2 or 3 person operation, and I would have to get buddies in, and I'd have to pay out because I'd have to pull people off other jobs. So the price would go up. So that's the notion of expediting. So the idea of crashing is to expedite activities in a project. Where do you think you would expedite activities? Which activities? Huh? The critical path. Exactly right. Now, the interesting thing about the crashing process, we're just having a sort of a little 2-cent conversation about this. Of course, they're going to be critical path activities, because if you don't crash on the critical path, you're not shortening your project. So why bother? Now, the interesting thing is that as I crash, let's suppose I crash this project. Let's suppose I found a way to get E a day shorter by coughing up some extra cash. What you're going to immediately see is that, sorry, not E, but E a day shorter. Remember I had the 2 5s? Then all of a sudden, path BCE and BCD would both be simultaneously critical, right? If I were to shorten E to 5 days. So if you're going to crash in a project where multiple paths are critical, what do you think you're going to have to do? To shorten all critical paths simultaneously. So I would have to look at the cost of crashing activities, path BCD and BCE, and take the minimum cost way to get them a day shorter, both of them. So it becomes actually an interesting exercise. If you just look at the cost of crashing each activity, you might be misled. It might be very cheap, for example, to crash activity A, but it doesn't mean a damn thing in terms of shortening the project. I could maybe shorten A's activity time from 4 down to 2 by chipping in an extra $50. I'm not going to do it. It's not going to help me. So if we did go through some of these problems, you'd find some pretty non-intuitive outcomes. You'd find that may crash some of the activities partially, not the whole way down. So for example, in that tiling example I gave you, I said I could do your 4,000 square foot house in, say, 6 days. My minimum would be 2 days. You might elect to go and have me do it in 4 days, because it might be more effective to do it in 4 days. Crashing it all the way down to 2 days may make no sense, because there may be other paths somewhere in my house maintenance project that would militate against me taking it all the way down to 2 days, because I can't really use that much savings. Right? Other paths would remain critical. Right? So the broad idea with crashing is that it's a systematic process that you'd go through. You'd use software to do this, and the outcomes are often highly non-intuitive. So I really point you in the direction of software if you're going to be expediting, because you might make some really dumb decisions otherwise. Now, I've just described the